Okay, so today we're doing LeetCode question 150, evaluate reverse polish notation. So what this problem is basically asking is you're given an array of strings called tokens that represent a arithmetic expression in a reverse polish notation. So to say this in simple terms, right, they want us to evaluate the expression and return an integer that represents the value of said expression. What does this mean? Well, looking at tokens, right, because it's mentioned it's an array of strings. This is what token is looking like to give you an image representation, right? And what we want to do is basically go through each value, right? For example 1, we're starting at 2. We read 2, we read 1, and then there's a plus sign, right? We're going to want to add the values behind the plus sign or whatever operation that may be, right? And then continue on the loop, right? In this instance, you have 3 and you have a multiplication symbol. So what you're going to do is you're going to add the values or do whatever the operation is saying to the values before it. So for plus, because the values before are 2 and 1, we're adding them. And we are multiplying here. The value before the multiplication is 3. So we add the 2 plus 1, we multiply by 3, and that's why the output should be 9, right? Now, it's looking at example 2, right? This is where it gets a little bit more complicated because let's say, for instance, the token is with the numbers that it has, that there are more than 2 integer values is what I'm trying to say. So you're reading tokens, right? 4, 13, 5, division, right? We can't just divide 14, 13, and 5. Like, division is a two-way street. So how are we doing that? Well, what we could do, or what we have to do, is grab the 2 values before any operation symbol, do that operation, and continue along the list. So what this means is this is why you see 13 divided by 5, because those are the 2 values before the operation. And then we have the plus sign, and what's left? 4. So we add whatever we get from 13 divided by 5 by 4, and that is why the output is 6. So we have an idea like, okay, if we're going to see an operation, right, whether it's a plus, multiplication, division, whatever, that we want to grab the last 2 values from it, do that operation, and continue on to the list. How can we do that? Well, a way we can do that is by using a stack, right? Stack is first in, last out, and how this is going to help us is we can add values on top of that stack once we reach a certain condition. This condition probably going to be whether we reach an operation, a plus, minus, multiplication, or so on, right? To grab the last 2 values from the stack, which are going to represent the last 2 numbers from wherever we're at, right? And do the operation. So we have an idea. We've kind of formulated what we should do into words. How are we going to see that in code? Well, obviously we're going to have to create a stack. So let's create one, right? Beautiful. And we want to traverse through tokens, right? The array here. So we could use create a for loop, right? For t in tokens, what are we doing? So we're just going to put looping through tokens, right? What are we doing here? Well, we need to set a condition, right? Remember how I said that we are looking if we are before, or we're looking for values before a specific operation, right? Meaning we need to know if we're in an operation as the moment, if t equals an operation. So how we could do that is, instead of just writing multiple if statements, just write one. If t is in string, and we're going to perfect. Okay. So what this is saying is, okay, so we're traversing through tokens, right? And t is representing each value, 2, 1, plus, whatever it may be. If t, or whatever index we're in, is equal to a plus, a minus, division, or multiplication, any operation that we're looking for, then do the things within the code. What are those things? Well, we are going to have to do some math here. This is where we go and kind of realize, okay, symbol here, let's grab the last two numbers and do something, right? So we need to set values for the first pop and the second pop. A way we could do that is by literally just setting values, right? Stack.pop and stack.pop, right? So now we have the last two values set equal to the variables b and a, right? Now we could play with those variables and add them, subtract them, whatever we want, because there are names attached to it, right? However, we do need to know when and how to use them. So what I'm referring to is we need to see, okay, well, if t is equal, right, to a plus sign, then do whatever, right? In this instance, that whatever is going to be stack.append, right, b plus a. Or I think a plus b looks nicer. There you go. And you are going to basically continue following this list, right? This will be a minus, this will be a multiplication, minus, multiplication. Beautiful. Well, let's change these to elif. Okay. Else. Beautiful. Okay. So we have the for loop. We're traversing through tokens. We're checking if t is equal to any of the operations. If so, pop the first two stacks, right? So now you have the last two values set equal to b and a. And now we need to check whatever t may be equal to. So if it's a plus, add those values together and add them back into the stack. If it's a minus, it's multiplication, vice versa. For division, division's a little bit different because we actually have a rule here saying the division between two integers always truncates towards 0. What does this mean? So this is a very unique response. It's particular for this question only, so we need to make sure that we follow the rules that set into place, because we will get a wrong answer or output if we don't. What this means is, let's say for instance, if the division result that we get is less than 0, we want to round up to the nearest whole number, right, to get closest to 1 as possible. And it's vice versa. If it's not, right, if it's not less than 0, then you're just going to round down to the nearest whole number. So how that would look is we're going to create a variable called division, and we're going to just do, we're going to grab a, we're going to grab b, and we're going to divide them, right? And instead of just automatically appending, we need to make sure that if division is less than 0, right, we want to append, obviously, but not just append whatever division may be, but we actually need to call this function called seal, right, and then pass division within, and then we are actually going to do a quick else statement, and I'm going to explain to you what we're doing in just 2 seconds, because I believe it's easier to kind of just see both things at the same time. Okay, so what this is doing right here, right, the seal is rounding up to the nearest whole number because it's less than 0. Remember how I mentioned if it is, this is what we're going to need to do. This function is what helps us do that. Else, right, else we are just using the floor, which all that does is just round down to the nearest whole number. Beautiful. Okay, so this is basically checking these operations, but what happens if it's not? If it's just a number? Well, if that's the case, then all you need to do is create an else statement and just do stack.append int t, right? And all this is doing is literally just adding a number. So if it's 2 or 1, just add it, right? Beautiful. And then last but not least, with all of this being done, we are constantly having the operations within the stack, the first or the last two being added, subtracted, multiplicated, or divided, right? We are setting conditions and making sure everything's working. If it's not, then if it's not, what I mean by that is if it's not arithmetic expression, right, to just add the values into the stack, because we're going to be playing with them later. After all said and done, we should only have one value in the stack, and all that means is just return stack at index 0. Beautiful. So first let's give this a run, actually, see if this is even right. Nope. Name seal. Okay, I misspelled this. I believe it's like this, right? Beautiful. Okay, awesome. Let's make sure we pass all test cases. Beautiful. Okay. Awesome. So that's working. Before I ended the video, I did want to kind of show in a representational, visual way of how this would look like, right? So going back into the code, we've created a variable called stack, which this is what this is equal to, and this, what we have is tokens, right? So we will actually write tokens just so everything is out in the air. So this is our tokens, and we're traversing through each value, right? So you have a 4, we're going to add that into the stack, right? Because remember, in the code, if it's not any expression or operation or whatever, we're just adding the value to the stack. 4 is just a normal value, so we add that, and we continue, keep it pushing, right? 5 is a normal value, you write it. 10, normal value, you write it. Multiplication. All right, what happens? We pop the first 2. We're going to grab 10 and 5, right? B is going to equal to 5, and A is going to equal to 10, right? And if T equals plus, then we add them, right? In this instance, we're multiplying right here. If it's multiplying, just multiply A by B. So 10 times 5 equals 50. Beautiful. Now as we have 50, we are adding that value to the stack. So what that does is we just need to remove this, right? Because we already removed these with the pop, and drop the 50 in here and continue pushing, right? Plus. Okay, if that's a plus, then we are going to grab the, well, first the plus here, that means B and A. We're going to pop these 2 values, right? So B is going to equal to 50, A is going to equal to 4, right? We're multiplying, so, or actually no, we're adding, so right here, stack that append, A plus B is going to equal 54, right? We pop these so there's nothing in the stack. We added the results, 54, and we've basically ran through the entirety of tokens, so there's nowhere else to go. Notice how there's only 1 value left in the stack, which is why when we do return stack at index 0, there is literally nothing besides the answer that you're looking for, and you're going to return 54, and that's going to pass all the test cases, and you have basically figured out the problem and evaluated reverse polish notation. With all that being said, I think it was pretty clear what is happening. This question is not too complex. Stack was the primary data structure used for this question. You use a for loop. You have conditions within an if statement to make sure that everything's working. And if you're not running those conditions, then all you're doing is basically just adding values into the stack. Once everything is said and done, then you return stack at index 0, which is going to return the first and only value within.